A disk is rotating at an angular velocity of 4 radians per second about its axis. Calculate the magnitude and components of the instantaneous tangent velocity at a point on the rim. So the tangent velocity is the cross product between the angular velocity and the radial vector. So using the determinant method, we'll write the angular velocity components in the first row and the radial vector components in the second row, which you can obtain using trigonometry. So that's going to give you the horizontal and vertical components of the tangent velocity. And to obtain the magnitude, well, you simply multiply r by omega. And for part B, the average angular acceleration is equal to the change in angular velocity on the change in time, which is the final minus the initial angular velocity on 3 seconds. And this will give you an answer in radians per second squared. And because it's negative, the angular acceleration will be clockwise and pointing inside the screen. A tyre has a diameter of 35 centimeters, and at point A, the tangent velocity is 15 meters per second at the instant shown. And part A asks for the velocity at point B on the rim. Well, we know that VA is r omega, with the angular velocity is uniform on that planar rigid body and points out of the screen. So given VA and the radial distance to point A, we can calculate omega, and then a tangent velocity at B is equal to the radial distance to B, which is half the diameter, multiplied by the angular velocity, which we obtained from this equation. Now in part B, if the tyre started from rest, how much time would point A take to traverse an angle of pi radians? And assume a constant angular acceleration. And we also know the angular velocity from the previous part of the question. So therefore we use the following equation from the big 5 kinematic equations for a uniform angular acceleration. And you'll be able to solve for the time. A tyre has a diameter of 35 centimeters and rotates with an angular acceleration that depends on time. Now derive an expression for the tangent velocity at a point located at some distance r from the center of mass. So we know that Vt is r omega, and we're given an initial angular velocity of 4 radians per second. So using the differential equation that relates the angular velocity to the angular acceleration, we substitute for the angular acceleration, then separate the variables, then integrate both sides. So from the initial to the current angular velocity, and from the initial time of 0 to the current time t. Then from that, you'll get an expression for the angular velocity as a function of time, which you can substitute into this equation to get an expression for the tangent velocity.